Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to Lost in Science for another week. This is 30 minutes of science ready to go. Some of, well, what I reckon is going to be some pretty interesting science for you to listen to this week. My name is Claire, and this week on the show I have a guest, actually. It is Professor of Microbiology Dee Carter from the University of Sydney, and Dee is going to chat to us about honey, but not just any type of honey. This is honey that comes from honey ants, and Dee's just published a paper that shows that this honey ant honey actually has some pretty incredible antimicrobial components that give it some powers potentially we haven't ever seen before. So protect us against things like fungi and molds. I don't know if you've seen honey ants before, but you really need to look them up. They are beautiful and giant, and just to have all this honey in their butts, they are brilliant. And Stu, what do you have for us on the show today?
Well, science has a long history, and some of the sciences that we know and love may have not been as exemplary in the past as how we think of them now. And I'm talking about zoology and, well, I'm also talking about botany as well, which is kind of close to me. But early in the history of European settlement of Australia, there was a lot of people who thought they were doing good things with botany and zoology, and they brought a whole lot of plants and animals to Australia that really don't belong in Australia. They did think they were doing the right thing. They also didn't really know what they were doing at all. And they also sent a whole lot of Australian animals all around the world as well. But I'm going to be talking about them later in the show. That's the Victorian Acclimatisation Society, and also there was acclimatisation societies all over the place back in the 1800s. So just a little bit about what they were doing and why they got it so wrong.
Well, stay tuned for that, and on with the show. Did you know that honey has potent antimicrobial activity? Maybe you've seen it sold as Manuka honey or raw honey. Well, new research recently published reveals that there is actually astonishing medicinal value in honey produced by another more unexpected insect, the honeypot ant. And in a world where antibiotic resistance looms large around the corner, this ant could offer a new hope and a new solution. To speak to us about this research is one of the authors of the recently published paper, Dee Carter, Professor of Microbiology at the University of Sydney. Dee, welcome to Lost in Science.
Thank you very much.
So these honey ants, how and why do they produce this incredible honey?
So I guess the first thing to bear in mind is that the way the honey is produced and stored is completely different to bees. Mm-hmm. So these ants actually produce and store this honey in their own bodies. They live in a pretty large nest underground, and within this nest, certain members are designated as what we call repletes. And these repletes get fed the nectar and the other things that the other ants, the worker ants and the colony forage. And this goes into their abdomens, and their abdomens swell up with this golden honey-like substance until they reach the size of sort of a smallish grape. So
Wow.
these ants look incredible. They've got little ant bodies at the front, normal little ant bodies, and then this amazing swollen abdomen full of golden liquid at their rear.
So does that mean they immobilized? Can
They
they sort
are
of...
basic, yeah, they really can't move around much. And in their nest, they basically cling to the ceiling of these small chambers in which the repletes live. So they live sort of separate from the rest of the colony in these chambers.
Wow. So they're sort of like living honeycomb.
Yes, that's right. Yes. And in times of scarcity, then the workers will stroke their antenna and the ants will cough up the honey and feed it back to them. So they are basically a living pantry for the colony.
Oh my God, life never ceases to amaze me. That is incredible.
It is really incredible.
Yeah. So what initially motivated you to undertake this research on honeyant honey?
So my group has had a sort of an ongoing interest in honeybee honey for a long time. It's not the major thrust of the lab, but it's been a sort of a side interest that we've had going along for many years, particularly Manuka honey, but more recently the sort of non-Manuka bee honeys as well. And some years ago, actually, Andrew Dong, who's the lead author on this paper, he approached me, and he's a former food science student, and he was really interested in indigenous foods. And so he said, look, I'm really interested in this honey pot ant honey. Do you think we could test it in your lab? And I said, yeah, sure, just get us the ants. But it took Andrew a while to then source the ants, and he had to travel out to Western Australia and join a tour that's there, which is specifically for digging for these ants run by Indigenous people. So then he was able to bring these ants back, and then we were able to test the honey.
Brilliant. And you've found that this honeyant honey, it has some quite interesting, potentially unexpected antimicrobial activity. Can you tell us a bit about what you found?
Sure. So, yeah, it's very interesting because in contrast to bee honey, which tends to be pretty broadly active. So if it affects one bacterial species, it'll probably affect a whole range of them. Whereas this honey was very specific. So it really affected Staphylococcus aureus, which you might have heard of as golden staph. But other bacterial pathogens didn't seem to affect at all. So it seems to be much more of a specific kind of activity. And it was also pretty active against certain species of fungi, so certain yeasts and molds as well. So, yeah, it seems like it's perhaps geared up to be active against certain things, but not others. And perhaps this relates to the ant environment, because they don't necessarily want to kill all the bacteria and fungi in their environment. They might have some that they like to keep going. So it's sort of less broad spectrum. It's not sort of like blanket kill everything. It's much more selective.
Yeah. And just to, I guess, rewind a little bit and get my head straight about, I guess, the evolutionary reason of why insects like honeybees and, of course, the honey ant, why there's a need to have this sort of antimicrobial function in their honey in the first place.
Yeah, and I think that's really the crux of it is, what is the evolution of this? And clearly, if you're making a sticky, lovely substance like honey, which could be great food for fungi and bacteria, especially if it gets a bit diluted, because normally it's so sticky and sweet that things can't grow in it. It's got too much sugar in it.
It's like a natural preservative type thing.
Yeah, that's right. But if it gets a bit diluted and gets spread around the colony, you can imagine that it could easily be overrun by particularly fast-growing molds that might really damage the nest and also potentially infect the ants or bees. So I think evolution has come up with this system, but perhaps evolution also, in the case of the ants, has also come up with a way of making sure that it can kill certain fungi and bacteria, but not everything, just so that it's not necessarily killing off everything in the environment.
As a microbiologist, you're looking at, I guess, what is contained within the honey that is the actual sort of like quantifiable antimicrobial component. What did you come up with?
Yeah, so it looks to us like it's a different mechanism of activity to bee honey. So bee honey, we know quite a bit about what causes the activity there. But this didn't seem to be the same. It didn't have the same properties that we would expect from the particular antimicrobials that we would see in bee honey. And in particular, what we found was when we heated it, the activity was largely lost. So we think it's probably something like a protein or a peptide, potentially derived from the ant itself. So in bee honey, a lot of the activity comes from the nectar that the bees forage on. Certain things also can come from the bee, but we think in the ant honey, it's most likely to be coming from the ant. But we don't know for sure, so we haven't done the tests yet, and we haven't been able, because we just don't have much of this honey, to actually do any sort of refined chemical tests to try and extract out what might be active. But we're hoping that we might be able to do that in the future.
Is this something, I guess, looking to the future as you must be, is this something that you think could have a place in our fight against antibiotic resistance in the future?
Yeah, well, we would hope so. Obviously, you would never be able to grow these ants in numbers. This is not an organism you can domesticate, and anyway, the amount of honey that's produced is tiny. But what we could do, if we can understand what the property is of this honey that's making it antimicrobial, perhaps we can use that as a lead compound to synthesize something that's similar. But it's certainly interesting in the sense that it takes us into a slightly different direction to most antimicrobials, and that could be really useful.
There must be something incredibly exciting about that. Your research group was collaborating with Indigenous communities who traditionally use the honey ant in cultural and medicinal practices and have a lot of knowledge around the honey ant. So can you tell us a little bit more about how the research was informed by Indigenous knowledge and collaboration with the knowledge holders?
Yeah, so the reason Andrew was interested in the honeypot ant honey was that there was evidence that Indigenous people had been using it in terms of for sore throats and infections and cuts and grazes as well. So it did seem that, in fact, it was being used already by the Indigenous people. Now, clearly, they dig for these ants, and a lot of the pleasure that they derive from them is simply because it tastes good, and it is actually, I haven't tasted it myself, but everybody who has says it's very nice. It's not quite as sweet as honey. It's a bit more tart. But it's also very culturally significant. So digging for the ants is something that people do in groups, and it's sort of a really pleasant way to spend the day, just digging for them, finding them. But they're also very aware of the sustainability of it. So they don't dig up entire nests. They just take a few ants at a time and then put it back together as best they can to make sure that it's sustainable and it's still there for future generations.
So you mentioned a little bit about future research. What are the next steps for this research for you sort of going forward?
So that really will depend on being able to source more ants if we can. We have been offered some more from other Indigenous groups, so we might end up with enough that would allow us then to give some honey to chemists, and they could help us determine exactly what is the magic active ingredient in that honey.
It's incredibly fascinating research to think about these replete ants, potentially having life-changing consequences for humans in the future. Dee Carter, thank you so much for joining us today and talking about the little ant that could, hold the power to combat some big bugs. So best of luck with the future of the research, and I'm looking forward to hearing more.
Thank you. It's really a pleasure to have this opportunity to talk about it.
What are you onto? Anything of interest to the scientific community?
Together,
you and I are going to make the greatest single contribution to science since the creation of fire.
It's a big scientific experiment. What do I know?
Across Australia on the Community Radio Network, you're listening to Lost in Science.
Now, I know you have young children, Chris.
Yes, that's true.
Have you taken them to the zoo?
Of course.
Yeah.
It's like a standby thing to entertain small children or to entertain the parents, particularly while babies are too young to appreciate anything in the world. You see a lot of parents just wheeling prams around the zoo.
I mean, it's a nice walk as well. Certainly,
yeah.
It's certainly the local zoo here is. It's actually a zoological garden if we're going to be technical about that. So you do get to walk around and look at the gardens as well. No, I know. My son used to love it. He's quite old now, so whether he's been to the zoo lately, probably not. I think. But I've got to say, the zoo now is an improvement on what it was like. Even when I was a kid, it was pretty grim in some places. There was literal monkey cages and things like that I still vaguely remember.
Yeah.
And when I was very little, it was only relatively recently they'd stopped doing things like elephant rides at the zoo and things like that.
Oh, really?
But yeah. It was a big deal when they stopped doing them, apparently.
Yeah, if you go to the Melbourne Zoo, I think one of the things that people, I think, makes an impression on people is they have one of the old cages there on display to show you how small they were and how much it compares with current zoos. Yeah, and it's always kind of shocking.
Yeah, and concrete floors and bars and the whole bit, yeah. But look, zoos mostly these days attempt to recreate habitats similar to the natural environment where the animals that they house actually came from. So they try and, sort of give them a bit of their natural habitat in the zoo. And obviously zoos are involved in contributing to conservation efforts, trying to keep species safe from extinction. But if you look back on the history of zoology and the zoological organisations in Australia early on in European settlement, they did some pretty questionable things, and where the zoos came from, it's probably worth diving into this. So as soon as Europeans arrived in Australia, they basically brought in exotic plant and animal species that did not naturally occur in Australia. And Australia is home to many species of animal that basically still exist because they were isolated from other species of animals in other parts of the world. I mean, the fact that...
Oh, right.
The fact that, our extinction since European settlement is pretty poor, and it's partly because the animals in Australia didn't know how to cope with other animals coming in, that they didn't know how to react to them or run away from them or, hide from them or whatever. So, I think probably an early example of bringing in things to Australia, one of the examples that's kind of held up as a good thing that happened was the Royal Botanic Gardens in Melbourne, which was founded to bring in plant species from all over the world, basically as a botanic garden to see what would survive in Victoria, because Europeans didn't really have any idea what was going to do well here. So the founder of the Botanic Gardens, Baron Ferdinand von Mueller, had imported thousands of living plants and had distributed tens of thousands of seed packets to gardens and people all throughout Victoria by 1858. One of the things he brought in, you may be familiar with, Chris, is the blackberry.
Oh yeah, they're normally feral, aren't they? I mean,
yes. So he did bring in the blackberry to see if it would survive. It did. It survived very well, and it's now one of the bigger, most widespread weed problems that we still have to deal with in Australia. But look, his success encouraged similar thoughts in some people about animals. And a zoo was set up on the banks of the Yarra River in Richmond, which is not where the zoo in Melbourne is now. It was on the banks of the Yarra in Richmond. And originally, from what I can read, the the zoo was originally to house newly imported animals before they were released into the wild. They weren't intending to maintain them in the zoo. It was just somewhere to hold them until they got around to letting them go somewhere. And I think that's a pretty unusual approach to zoos compared to what we think of them now. Anyway,
so what kind of animals did they have there?
All sorts of animals. So they'd already brought in before the 1860s. They'd already brought in alpacas and camels and llamas and donkeys. Now, the alpacas and llamas aren't a feral pest problem in Australia, but the donkeys and camels are, and they date back all that way to someone letting them go somewhere, basically. But this kind of activity was encouraged by a group of people called the Victorian Acclimatisation Society, and their aim was to do what they saw as they saw themselves as filling in the gaps in the ecosystems of Australia by bringing in animals from elsewhere, which is obviously completely misunderstanding what ecosystems are, but this actually predates ecology as a science as well. So they didn't really have any understanding of what they were really doing. But they were specifically responsible for releasing starlings, which are a kind of bird, which are quite common in Victoria. Sparrows, which didn't exist here before the Victorian Acclimatisation Society brought them in. They brought in European carp, which they released into the river systems, and they cause huge problems in our river systems.
Carp, as Barnaby Joyce is fond of saying.
And they also brought in sambar deer and let them go.
Oh, okay.
Which are originally from Sri Lanka, but obviously feral deer cause all sorts of ecological problems in the forests where they roam free now. So all of them are now feral pests in Australia, but that was just a tiny glimpse of what they actually intended. They even talked about releasing monkeys into the Australian bush. And the justification for that was that they would entertain people in the countryside because there'd be funny monkeys to watch when you're out in the bush. I mean,
why not?
But that's literally the extent of their reasoning, of their rationale for bringing monkeys to Australia. We'll just let them go for entertainment's sake. And the idea behind this acclimatisation society, and they were all over the country, they were all over the world as well, and they did even send Australian animals to other countries. So they sent wallabies and kangaroos to Europe, and there was some wallabies in France that I think still there is a population, very small population. They were the ones who sent possums to New Zealand, which New Zealanders are not very happy about.
No.
And they have, sort of altered their ecosystem over there as well. So they weren't content with just ruining the local ecosystem in Australia. They really wanted to expand and send potential pest animals all over the place. But yeah, their idea was that animals would adapt to their new environment over time, and that does seem to be the case because all the species that they brought here that have survived have adapted to their environment. It's just that they've also altered their environment, so they've changed. Animals. There's complex relationships between animals and plants, and animals and each other, and all sorts of things. Which is, the basis of the ecosystem is the interaction of all these parts. If you bring in a new part, it's going to completely alter the ecology of the area, and that is what they've done. I mean, rabbits are probably the most famous example, but and they were again imported on purpose. They were not an accidental importation. But while they've been doing that, they've in many cases reduced the extent of animals that were here in Australia before they arrived. So they've greatly increased the rate of extinction, of Australian species. Now, one good thing, I guess, is that the Victorian Acclimatisation Society was only really active for 11 years, between 1861 and 1872, where they kind of morphed into being the Victorian Zoological Society, who then established the Royal Melbourne Zoological Gardens, and that is the zoo that we know in Melbourne. That's still there in Melbourne, but they obviously changed their approach to exotic animal species and weren't just importing them to let them roam free in the countryside, and they're obviously a lot more focused on preservation than on alteration of the environment, which is what they seem to have been focused on originally. But I think it's an interesting idea that these kind of organisations, which seem to have been, claimed to have been some sort of scientific basis for what they were doing, but really they just did a lot of damage by working really hard for a short period of time and not actually knowing what they were doing.
That's all we have time for on another episode of Lost in Science. Thanks for joining us. Lost in Science is recorded on the lands of the Kulin Nation at the studios of 3CR and broadcast across Australia on the Community Radio Network with the kind support of the Community Broadcasting Foundation. If you would like to get in touch with us, we would love to hear from you. You can email us at lostinsight@gmail.com. You can find us on Facebook, where we are Lost in Science on 3CR, or try us on Twitter, where we are Lost in Science 1, or just tune in again next week, wherever you listen to us, when Stu, Claire and Chris get Lost in Science.
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.